Now I'm discussing about torque. Torque. Simply, I'm concluding the topic torque. In translatory motion, if the body is in motion, translatory motion, the body comes to rest or the body still it continues its motion. One thing is essential, and that is force. For continuation motion of the body in the translatory motion, or already the body is in motion, I need to make the body is at rest. For that purpose, I need one essential agency that is called force in translatory motion. Whereas in rotational motion, if the body is at rest, want to be in rotational motion, or the body is in rotational motion, want to be at rest, one essential agency is required, that is called torque. In brief, in rotatory motion, without torque, no body is in rotational motion. Okay, now what is the torque? Torque is nothing but it is a product of force and perpendicular distance. Force and perpendicular distance. Okay, now what is the SI unit? Unit is of force is Newton. The SI unit dimensional formula. The force dimensional formula is MLT minus 2. The distance dimensional formula is L. M L into L square T minus 2. This is the dimensional formula of torque. Torque, work, energy, all these are having same dimensional formula. Torque, work, energy, either kinetic energy or potential energy. Simply I'm calling it as energy. So all these are having same dimensional formula, that is ml square t minus 2. In vector form, torque can be written as tau bar is equal to r bar cross f bar. In vector form, torque is nothing but tau bar is equal to r bar cross f bar. R bar cross f bar. Okay, now here I'm taking some questions related to the torque. Tau bar is equal to r bar cross f bar. Okay, now first I'll take this question. A particle is projected at time t is equal to 0 from a point O with a speed u at an angle theta with horizontal. Find the torque acting on projectile. Okay, now listen. In this, at first, a particle is projected at time t equal to 0 from a point O with a speed u at an angle theta. So I'm taking one plane, x-axis, y-axis, and a particle is projected like this with the speed u bar by making an angle theta with the horizontal, and thereby it follows a parabolic path. Now we need to calculate the torque. Torque is equal to force into perpendicular distance. So here I am representing in the form of vector. So tau bar is equal to, what's the formula? R bar cross f bar. So here at first I need to calculate the r bar. Afterwards I need to consider the f bar. So for that purpose, this is the origin. R bar. What is the position vector? What is the position vector? R bar, here I am taking it as Rx I cap plus Ry j cap. In the vector form, we used to write like this. R bar is equal to, how come we consider that? Rx I cap plus Ry j cap. Rx I cap plus Ry j cap. Then Rx. R means distance. Distance is equal to, general formula is, what is the general formula of distance? Speed into time. What is the general formula of distance? Speed into time. Getting? So now here Rx is equal to speed. This is the x-axis, right? Along the x-axis, what is the velocity that we need to consider? Along the x-axis, if you want to calculate the distance, for that, along the x-axis, what is the velocity that we required? So u bar is the velocity resolved into components along x-axis u cos theta, along y-axis u sin theta. General concept, resolution of a vector. U bar is a vector making an angle theta with horizontal. So u bar resolved into components u cos theta, and this is u sin theta. So Rx is equal to, what is the velocity along x-axis? U cos theta. What is the time to reach this point? T. Next, Ry is equal to, so now here I am taking the general equation. Sy is equal to Sy is equal to Uyt plus half Ayt square. Equation of motion. S is equal to Ut plus half At square. Along the y-axis I required. So that's why here I consider that Sy, Uy, Ay. Sy, here I am taking Ry. Uy, what is the vertical component? U sin theta into T. Body is projected upwards. So A is equal to minus G. Plus into minus, minus half G T square. Now, substitute these values in the equation. R bar. Now, R bar is equal to, what is the Rx? What is the Rx? U cos theta into T I cap plus, what is the Ry? U sin theta into T minus half gt square. What's the value? J cap. R bar is equal to u cos theta into T I cap plus u sin theta into T minus half gt square into J cap. This is R bar. Then what about the F bar? If the body is moving upwards, either upwards or downwards, whatever it may be, the weight of the body acts vertically downwards. So F bar is equal to, what is the weight? Mg. How it acts? Downwards. Downwards means what? Negative y-axis. Downwards means what? Negative y-axis. This is the positive y-axis, upwards. On the positive y-axis, what is the unit vector? J cap. Downwards means negative y-axis. Negative y-axis means minus y. Minus y means what is the unit vector? Minus j cap. So here negative unit vector minus j cap. Why? Because the body is moving downwards. Along the negative y-axis, the body is moving. Nothing but the weight of the body is considered. So F bar is equal to mg into minus j cap. And now apply. Tau bar is equal to R bar cross F bar. That is equal to, here I cap, j cap, k cap. I cap, j cap, k cap. Now at first take R bar. Here what is the first one? I cap. Before I cap, what is the value? U cos theta into T. What is the j cap? This entire part is j cap. U sin theta into T minus half g T square. This entire part I need to consider. Okay. So this is one method. U sin theta. Entire based on this here, this entire value here, I'm taking it as like x. So here I'm writing in the place of this, I'm writing as x. K cap, there is no k cap here. 0. There is no k cap, 0. Now, f bar. What is the I cap here? There is no I cap. Mg into minus j cap here. We don't know I cap value. So 0. What is the j cap? Minus mg. Here, what is the k cap? There is no k cap here. 0. Now, I need to solve this. For that, here, listen. Listen. At first, take I cap. I cap. If you are taking the I cap, just close this. Close the I cap. X into 0, cross multiplication. Close the I cap. X into 0, cross multiplication. 0. 0 into this one. Again, cross multiplication. 0. So here you will get 0. This is plus. Alternatively, change the sign. Minus j cap into. Now close the j cap. Close the j cap again. If you close the j cap, again cross multiplication. U cos theta into 0, like this. Cross multiplication. U cos theta into t, 0. 0. 0 into 0, again cross multiplication. 0. Again j cap also 0. Change the sign. One time plus, minus. Again plus. Need to keep k cap into. Now k cap. Close the k cap. You will get cross multiplication. U cos theta into t into minus mg. Into minus mg. Need to cross multiply here. U cos theta into t into minus mg. Minus is mandatory. Once you close the k cap and these two you multiplied, now again these two cross multiply. X into 0, 0. X into 0, 0. So now 0. Okay, from this is 0, 0 minus mg t u cos theta into k cap. Just I rearrange the terms here. Mg t u cos theta into k cap, and this is tau bar. If you want to take the tau, modulus of tau bar is equal to magnitude. If I required, this minus became as plus k cap unit vector. The magnitude of unit vector is equal to 1. So the remaining term is mg t u cos theta. This will be the answer for that. Okay. Now another problem. This is another problem. Force 2i cap plus 7j cap, one force. 2i cap plus 5j cap plus 7k cap, another force. I cap minus 2j cap plus k cap. This is another force. So three forces are there. 1, 2, 3. So take the calculation of net force. F net is equal to, add all the three forces. F1 bar plus F2 bar plus F3 bar. Now F net is equal to F1 bar 2i cap plus 7j cap. F2 bar 2i cap plus 5j cap plus 7k cap plus this value I cap minus 2j cap plus k cap. F net is equal to 2i cap plus I cap, 3i cap plus 2i cap, 5i cap, 7j cap plus 5j cap, 12j cap minus 2j cap plus 10j cap, and k cap, 7k cap plus k cap, 8k cap. This is net force. Now here 2 points mentioned. One is at 4 minus 1 2, the another one is 6 1 minus 3. Now at first I am taking that R1 bar is equal to, first point, what is the first point? 4 minus 1 2. X coordinate 4. So I'm writing it as 4 I cap. Along the x-axis, unit vector is I cap. What is the y coordinate here? -1. Along the y-axis, what is the unit vector? J cap. So -1 into j cap minus j cap, -1 into j cap minus j cap. And again, what is the coordinate here? 2. Z coordinate. What is the unit vector along the z axis? K cap. So now plus 2 k cap plus 2 k cap. Next, R2 bar is equal to R2 bar is equal to, what is the second point? 6 I cap, again 1 j cap, and again minus 3 k cap, minus 3 k cap. Okay, now I'm taking that R12 bar, nothing but R1 bar minus R2 bar, R1 bar minus R2 bar. Okay, so what is the R1 bar? This is R1, 4 I cap minus j cap plus 2 k cap minus R2 bar 6 I cap plus j cap minus 3 k cap. 4 minus 6 minus 2 I cap minus j cap minus j cap, minus into plus minus, minus 2 j cap plus 2 minus into minus plus 2 plus 3 5 k cap. This is R12 bar. Now I need to calculate moment of force. Either torque or moment of force, both are same. One more name of the torque is moment of force. If the word moment of force is present, we need to calculate the torque only. Now tau bar is equal to, again need to take that I cap, j cap, k cap. Now first R bar we need to consider. R bar, tau bar is equal to, what's the formula? R bar cross F bar. R bar, in this what is the I coordinate? I cap minus 2. What is the j cap? Before j cap minus 2. Before k cap 5. And then in this force, what is the value of 1 which is before I cap 5. Before j cap 10. Before k cap 8. Now we need to calculate this. We need to calculate this. See, tau bar is equal to I cap into, close the I cap, 8 into minus 2, cross multiplication, 8 into minus 2, minus 16, minus is mandatory. Next, close I cap, again 5 into 10, cross multiplication, 5 into 10, 50. Here plus, change the sign, minus j cap into, close j cap, minus 2 into 8, cross multiplication, minus 16 again, minus is mandatory. Again 5 into 5, cross multiplication, close the j cap, and 5 into 5, 25 plus k cap into what's the value? Close the k cap, minus 2 into 10, minus close the k cap, minus 2 into 5, minus 10, minus of minus 10. Now tau bar is equal to I cap minus 66 minus j cap into minus 41 plus k cap, minus into minus plus, minus 20 plus 10, minus value is greater, so minus 10. Now tau bar is equal to minus 66 I cap minus into minus plus 41 j cap plus into minus minus 10 k cap. This is a torque. Okay. Another one. Find alpha and beta if the force F bar is equal to 2I cap minus 3J cap plus K cap acting at 2 comma beta comma minus 1 produces no torque about alpha comma 0 comma 2. No torque about alpha comma 0 comma 2. Okay, so no torque. So torque is 0. In the problem very clearly mentioned the torque equal to 0. When the torque equal to 0, tau is equal to, tau bar is equal to, what is the formula? R bar cross F bar. So in the cross product, A bar cross B bar is equal to AB sin theta, RF sin theta into N cap. N cap is the unit vector acting along tau bar, resultant vector. Now, when it is 0, if theta equal to 0, sin 0, 0. 0 into anything equal to 0. Then tau is equal to 0. Very simple. So here theta equal to 0. Then tau is equal to 0. It means tau equal to 0 means theta must be 0. Theta must be 0 means what? How these two vectors are? R bar and F bar is parallel. If R bar and F bar is parallel, then only theta 0, then only tau 0. This is the link. Now, the condition if A bar parallel to B bar, A bar parallel to B bar, then what is the condition? AX by BX is equal to AY by BY is equal to AZ by BZ. This is the formula. AX by BX is equal to AY by BY equal to AZ by BZ. If the two vectors are parallel, then that condition must be satisfied by that by those two vectors. Okay. Now here tau bar is nothing but R bar cross F bar. What is R bar? R bar. R bar means we need to take these two vectors. Subtraction we required 2 I cap plus beta j cap minus 1 into k cap. This is R1 bar minus R2 bar we need to do alpha I cap plus 0 j cap plus 2 k cap. Now R bar is equal to, why? Because here 2 points mentioned. If 2 points are mentioned, then we need to calculate the position vector like this. For the first point, we need to represent the vector by taking the I cap, j cap and k cap. For the second vector also, we need to represent by taking I cap, j cap and k cap. We need to subtract. Then we will get the position vector. Then 2 minus alpha. In both the cases, I cap is common plus beta, j cap. Anyway, here 0 is present. No need to write. And then minus plus here minus 1, here plus 2. Minus 1 plus 2 k cap. Now R bar is equal to 2 minus alpha I cap plus beta j cap minus 1 plus 2 plus 1 k cap. Already you know that F bar given in the problem already 2 I cap minus 3 j cap plus k cap given in the problem. Okay, now I'm taking this condition AX. First vector is this only. So this is AX and this is AY and this is AZ. So AX, what's the value? 2 minus alpha by BX. This is BX. Second vector this is BY and this value is BZ. BX, BY, BZ. BX, what's the value? 2. 2 is equal to AY, what's the value? Beta. Before J cap, what is the value? Beta, that is AY. Then here, what is the BY? Minus 3, including sign also we need to consider. Minus 3 is equal to AZ. Before K cap, what is the value? 1 by, here before K cap, what is the value? BZ, 1 only, 1. We need to calculate, here, we need to calculate alpha and beta. That's it. So for that, here we are taking the concept it as, see here, this minus into plus. See here, this is minus into plus minus only. Minus 1, minus 2, minus 3 you will get here. Minus 3. So before k cap, what is the value? Minus 3. That is Az. Minus 3 by 1. Now, I need to calculate the alpha first. 2 minus alpha by 2 is equal to minus 3. Cross multiplication. 2 minus alpha is equal to minus 6. Minus alpha send that side, plus alpha. Minus 6 plus, take this side, plus 6. 2 plus 6, 8. Alpha value is 8. Then beta. Beta by minus 3 is equal to minus 3 by 1. Cross multiplication. Beta is equal to minus 3, 9. So alpha is equal to 8 and beta is equal to 9. Like this, we can solve this problem.